complex numbers, examples 14 and 15. In this pair of examples, we're asked to use the quadratic formula to solve quadratic equations. For number 14, it's x squared minus 2x plus 10 equals 0. Now, the fact they're asking it in FP1 suggests it's not going to factorise easily, so we'll just go straight to the quadratic formula. X is going to be minus b, which is 2, plus or minus square root b squared, which is 4, minus 4 times a times c all over 2a. Make sure you show you're working out when you do this. Don't just write down what you think the answer is, because then you'll lose method marks if you've made a mistake. So underneath the square root we have 4 minus 40, which is minus 36. And we were expecting that to be negative because we're talking about complex numbers, aren't we? So, tidying that up, square root of minus 36, think back to the very early examples, we split it up into root 36 times root minus 1. Root 36 is 6, root minus 1 is I, divide it by 2, and so the final answer is 1 plus or minus 3i. So that's example 14. Pause the video and have a go at 15 yourself first, and we'll see if we get the same answer. So for 15, we've got 2x squared plus x plus 1 equals 0. Same thing. X is minus b plus or minus the square root of b squared, which is 1, minus 4 times a times c, all divided by 2a. 2a is 4. So we have minus 1 plus or minus 1 take 8, minus 7. And so again we can split that up and we can write it as minus 1 plus or minus, I'll leave it as a third, root 7 times root minus 1. Now sometimes in an exam they ask you to give it in the form a plus bi, so just to be on the safe side I'd probably split it up and write the first part, the real part, as a quarter, plus or minus root 7 over 4 for the imaginary part.